Hi, everybody. I would like to introduce you a new problem. I hope that it will be interesting for you, but it's a different problem because usually when we do exercises, we have special exercise with proportions. We have the ideas which have got the direct proportions or indirect proportions. So usually we come up with one-sided problems, which include only direct or only indirect proportions. However, today we are going to consider a new problem, an interesting problem, which will cover not only direct proportions but indirect proportions at the one problem in one problem. Let's see the problem. First of all, let's read the problem. Problem one. If it takes 5 cats 2 days to catch 6 mice, how many days will it take 3 cats to catch 9 mice? So you can see here we have here three variables, cats, days, and mice. And we are requested to find the number of days for 3 cats to catch 9 mice. So before we pass to solving of such exercises, I would like to briefly explain what we mean by direct and indirect proportions because we are going to use these ideas here. So actually, what we have here in this case, we are going to consider two easy problems. Let's suppose that 1 kilogram of potatoes cost 3 monas. Then obviously 3 kilograms of potatoes will cost 9 monas. Let it be our first problem. And the second problem, let's suppose the distance problems or speed time problems. Let's suppose the car travels from one place to another place at 100 kilometers per hour, and it covers this distance for 2 hours. So obviously, in this case, 100 times 2 will give us the distance. And let's suppose now the car travels at a higher speed with double speed, 200 kilometers per hour. And this will make our time, of course, if the speed increased twice, so it's wise to think that the number of time spent is going to be 2 times less. So we are going to get 1 hour for this travel. So you can see now two types of problems. And actually, this type of problem is seen. The first problem is about the direct proportion, because here the number of kilograms, increase of the number of kilograms, also result in increase of monads, increase of price. So let's write here direct proportion. It's a direct proportion here. And the second example is the indirect proportion, because here we have got an obvious overview of speed increase, which results in time decrease. So corresponding decrease. So increasing in speed results in decreasing of time. So you can see when the increase of one variable results in increase on another variable, there is a direct relationship between them. In math, we are going to call it direct proportion. In indirect proportion, we have got just vice versa. Sometimes it's called inverse proportion. So obviously, we are going to consider, when we consider this problem, we are going to we are going to look through the same way. We are going to judge the same way. Now let's come back to our problem, and let's try to explain our problem in a good manner and try to understand what things are here. So as far as you know, we said that there are uh, 5 cats. Let's write what we have here in our table. So from the problem, we see that there are cats There are days spent to catch poor cats. Yeah. Hopefully, it's just in the problem, not in the reality. So we have 5 cats, 2 days, and mice. We have mice. Okay. So let's write what we have on the board. So 5 cats. They spent 2 days to catch 6 mice. And then comes the question, how many days? So let's suppose X days. Will it take 3 cats to catch 9 mice? Again, we have got here the 3 variables, cats, days, and mice. First of all, let's agree that we need to, first of all, clear the relationship between these 3 variables. Let's consider cats and days. So what kind of relationship is between them? So what do you think? For this purpose, let's judge like this. Let's suppose we increase number of cats. Then obviously, if number of cats increases, the time spent for catching mice will decrease because more cats means less days. So in this case, there is an indirect relationship between cats and days. So obviously, in indirect the relationship, what we do, we actually multiply the ideas. So cats times days. So we are going to multiply these ideas. We know it from our lessons that in indirect proportion, we use multiplication. In direct proportion, we use division. Now let's consider the question of relationship between cats and mice. So obviously we know that if there are more cats, then there are more mice caught. So it's natural to think that more cats, increasing the number of cats will lead to increase of the number of mice caught. So obviously they are directly related with each other. If there is a direct relationship between them, then we are going to divide these variables. So cats and mice, they are in direct relationship, then we divide them. So we have got the formula for solution of this problem. Now let's use this formula. So let's write everything in its place. So 5 cats times 2 days divided by 6 mice is equal 3 cats multiplied by x days. We are going to find this x divided by 9 mice. So the rest of the thing is just algebra. We can find like this. So 10 out of 6 is equal. We can cancel here 1, 3. So 1 and 3 here. So it's going to be x out of 3. So obviously x equals to 30 out of 6, which makes 5. So we found that x equals to 5 days. So the idea here is that it is 5 days needed to catch 9 mice for 3 cats. Now we are going to go on to another problem, which also is going to include ideas such as direct and indirect proportion. Let's write what we have. If 3 boys take 2 days to mow 3 lawns, how many boys can mow 6 lawns in 3 days? So we have boys, days, and also lawns mowed. Lawns. So let's write 3 boys, 2 days, 3 lawns. The question is how many boys can mow 6 lawns in 3 days? So how many boys? Let's suppose X boys, 6 lawns, and 3 days. So let's, like in the previous example, let's see the relationship between boys and between lawns. First, our first relationship between boys and days. More boys again means less days spent. So they are indirectly related. If indirect relation comes, then boys, we are going to take boys times days. Okay, so in indirect relationship, we usually multiply. And boys and loans. Now let's consider the relationship between boys and loans. If there are more boys working in the loans, then obviously more loans are going to be more. So we are going to have the direct relationship between them. So loans are directly related here. If there is a direct relationship, as we said in the previous mice and cats problem, then we are going to divide. So this is the formula for our solution of this problem, which we are going to use. So 3 boys, everything we write here. So 3 boys times days, which is 2 days, divided by 3 loans equals, again, x boys times 3 days divided by 6 loans. So obviously thinking we can have here some canceling. The 3 is cancelled. So we have 3x equals to 12. So from here we get x equals to 4. How we get 3x? Of course, this is the 3x and 6 is multiplied by 2, 12. So we have x equals to 4. So this is the answer to our question. So 4 boys will spend 3 days to mow 6 lawns. Now it has come the problem for your self-test. I would like to give a self-test problem whenever you have time. I would like you to go through it and write in the comment place the solution for this problem. Maybe you are going to also uh, explain in a different manner, which might take less time and which might be more interesting. So any ideas are welcome here. We'll be very glad to share it in our YouTube channel. Again, do not forget to subscribe to our channel and share it with with other people. And do not forget for your comments to post on the comment part. Thank you very much. See you in our next videos.